So looking back at our examples of exceptions to Mendel's rules, it's important to review again what we know about what Mendel did. He said that everything has two forms, and the two different forms of each one of them would be dominant. And the way they figured this out is that in the heterozygotes, the dominant one is the one that's expressed, and the recessive one is the one that's not expressed or not seen. And we saw the example of incomplete dominance where neither of the alleles are fully expressed, and we see a blending in the heterozygous. Now we're going to see what happens when they're both expressed. So sometimes we can have examples like in chickens where if we have homozygous, they're black, or homozygous W, they're white. But if there's one of each, they're heterozygous, we say that they're checkered or they're erminate. And so the checkered or erminate are these little speckled ones that you see here. And those would be, from a distance, they might still look gray, but you can definitely see the feathers up close are speckled. So in the example that you're given, it says that what happens if you cross a black chicken with a white chicken? And so we'll set that up here. Notice, again, we can't use capital and lowercase letters because they no longer mean anything. So we use these superscripts. So here's a homozygous black chicken, homozygous white chicken, and we want to know what are the possible offspring if we cross a black and white chicken. And notice that 100% of them will be speckled or checkered or erminate, however you want to call them. And again, with the superscripts, remember these two count as one letter, and we usually put them in alphabetical order, mainly just because then we don't get them mixed up. We see that all of these four are the same. Another example of codominance is blood typing. And blood typing, as I mentioned before, is also an example of multiple alleles. We have three options, even though each person still only gets two. They could have two of these, or two of these, or one of different combinations. If you end up getting A and B, both, you have type AB blood, and we say they are codominant. Now, in this case, we do have a little letter because I is recessive. So if I shows up with either A or B, it will not be seen or not expressed. So that's why people can have A blood, they can have B blood, they can have both A and B blood, or they can have two little i's, which means they don't have either of these chemicals sticking on their red blood cells. So let's look at the example that I gave you before you do one for yourself. So the phenotype for these would be which blood type. So in the first example, it says a mother who is IA little I and a father who is type AB have children. What are the possibilities for their offspring? So I know that we're going to put one parent across the top and one parent across the side. And then we're going to join them in each of the boxes. So bring one down, bring one across. Again, if you have a capital letter, you want it to be before the lowercase. And notice that we have a parent with A blood and a parent with AB blood, but we have children that could have A, AB, A, or B blood. And notice that for type A and type B, they can be homozygous or they can be heterozygous. So what are the blood type possibilities for their children? So there's only three possibilities, and it's 50% for type A, these two, 25% for type AB, and 25% for type B. So if we look at your assignment, I gave you the example that we went over with the chicken. Again, same thing as before. You can either make your text box or you can click and drag the little pieces that I already have for you. And you also have one blood typing problem where, again, you're given a blood type for the mom and dad, and you will need to figure out what possibilities there are for the offspring.